Assalamualaikum warahmatullahi ta'ala wabarakatuh. And hi, my name is Nawawi bin Azmi. Today, me and my colleague are going to present to you about convolutional neural network on fashion classification. Before we start, I'm going to introduce my colleague, which is Mardiaa Mardathi binti Ramlee, Nurul Husna binti Razali, and Nina Amiera binti Muhammad Faisol Saud. Now for the introduction. Nowadays, people use a lot of recognition for security reason and easy to access as you do not have to type or write anything all over. The work that we focus on is image classification. For this classification, we are using Fashion MNIST dataset. The dataset consists of a training set of 60,000 examples and test set of 10,000 examples. Each example is a 28 times 28 grayscale image related with a label from 10 classes. The labels are an array of integers ranging from 0 to 9.
Assalamualaikum, my name is Amiera and I will be presenting on the data analysis. In this data set, there's 70,000 data in the format of a pixel. And the size of the pixel is about 28 by 28. And then we have 784 as an input for the input layer. In the train set, there's 60,000 data, while test set has 10,000 data. Pixel is provided by the number range from 0 back to 255 white in the RGB coloring code. Uh, this will turn the image into grayscale format before processing the image. And then the pixels will be analyzed and turn it into binary to make it easier to read. And the binary is converted into images form and the output will be formed in the result.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mardiaa Mardathi binti Ramlee and I'm going to explain about CNN. There are three layers that make CNN, which are first is flattened layer, second is activation function, and third is fully connected layer, which is FC layer. When these three layers is combined, the CNN architecture will be formed. First is flattened layer. This is the first layer that is used to extract the various features from the input image. In this layer, the mathematical operations of flatten is performed between the input image and a filter of a particular size. By sliding the filter over the input image, the dot product is taken between the filter and the parts of the input image with the respect to the size of the filter. The output is termed as the feature map, which gives the information about the image, such as corner and edge. Later, this feature map is fed to other layers to learn several other features of the input image. Second is activation function. For this layer, their main aim is it decides which information of the model should fire in the forward direction and which one should not at the end of the network. It adds non-linearity to the network. There are several command use activation functions such as ReLU, softmax, 10H, and sigmoid functions. Each of these functions have a specific usage. For binary classification CNN model, sigmoid and softmax are preferred to use for a multi-class classifications. For third is fully connected layer. Fully connected layer consists of wakes and bias along with the neurons and used to connect neurons between two different layers. These layers are usually placed before the output layer and form the last few layers of a CNN architecture. The input image from the previous layer is flattened and fed to the FC layer. The flattened vector then undergoes few more FC layers where the mathematical operation usually take place. In this stage, the classification process begins to take the place. This is the picture of CNN architecture.
Assalamualaikum. My name is Nurul Husna Razali, and I would like to talk about our third experiment, which is the activation function. So, what we use here by default, our optimizer is Adam, and our epoch is 20. So, what we change here, our variable is which is the type of activation function. Uh, the type of activation function that we use, the first one is sigmoid, and then second is rectified linear unit, ReLU activation function. So why we use this? Because the main reason why we use sigmoid activation function is because it exists between 1 and 0. Therefore, it is especially used for model where we have to predict the probability as an output. Since probability of anything exists only between the range of 0 and 1, sigmoid is the right choice. The function is differentiable. That means we can find the slope of the sigmoid curve at any 2 points. The function is monotonic, but the function's derivative is not. So the other one, which is the rectified linear unit activation function, is most used activation function in the world right now, since it is used in the almost all the convolutional neural network or deep learning. So the ReLU is half rectified, which is from the bottom. It will change the value of function, uh, change the value of function on the Z axis from anything below than 0 into 0. This is because all the range is between 0 until infinity. So basically the rectified linear unit will change all the negative value or value less than 0 into 0, or the positive value, which is more than 0 until its value. So which is for example, if the value is -1, it will change into 0. So if the value is 1, it will not change anything, but it's still the value is 1. So basically it doesn't accept any value less than 0. So the function itself is both derivative and monotonic. So based on our experiment, the sigmoid, we can, for the ReLU, we can see our accuracy is 89% and our sigmoid is 88%. This is because ReLU is more accurate because it is both derivative and monotonic, but the sigmoid is only monotonic. So the accuracy is a bit lower than ReLU, but it is still acceptable. So for our experiment, we use image classification, convolutional neural network. So it is the best. We should use ReLU activation function. So that's all for me. Thank you.
Last but not least, for our result, we use Google Colabs to train and test our dataset. We achieve the accuracy of the dataset 89% and above. Google Colapse optimized our operation and it only consumed 1.29 gigabytes of memory. That's all from our team. Thank you.